All right, let's dive right in. Today we're going to peel back the curtain on reality itself and talk about quantum mechanics. It's the science of the super, super small. And down there, the rules we live by, they just completely fall apart.
So, let me just start by asking you this. What if something could be here and also over there at the exact same time? I know, it sounds like something straight out of science fiction, right? But in the quantum world, that's really just the tip of the iceberg.
Okay, so here's our game plan for making sense of it all. We'll start with this spooky new reality, then we'll break down the 3 weird rules. After that, we'll look at how we know it's real, see why your world is quantum, and we'll wrap it all up with the ultimate mystery.
So let's get into it. Section 1, a spooky new reality. You know, the whole story of quantum physics is basically about scientists realizing that the universe, at its most fundamental level, works in ways that nobody, and I mean nobody, could have ever imagined.
Think about it like this. In our world, the big world, things are predictable. You hit a billiard ball, you know where it's going to go. That's the classical world. But the quantum world, the world of tiny atoms and electrons, it's a whole different ballgame. It's not about what will happen, it's about what might happen. It's all about probabilities, weirdness, and these bizarre connections. They had to throw the old rulebook right out the window.
So, if the old rulebook is out, what's in the new one? Well, that brings us to our next section, the 3 weird rules. These are pretty much the core ideas you need to know to get a handle on this stuff.
All right, first up, wave-particle duality. So if I ask you, is an electron a tiny, solid particle, like a little marble? The answer is yes. But if I ask, can it also be a spread-out wave, like ripples in a pond? The answer is also yes. It's both. It just depends on whether or not you're looking at it. Crazy, right?
Okay, get ready, because rule number 2 is where your brain might start to melt a little. It's called superposition. This basically says a particle is in all of its possible states at once. It could be spinning both ways. It can be in a bunch of different places, all at the same time. And it stays that way until, and this is the key, until you measure it. At its core, reality isn't even fixed until we look at it.
Here's an easy way to picture it. Imagine you flip a coin. While it's spinning in the air, what is it? Is it heads or tails? Well, you could say it's kind of a blur of both possibilities. It's only when you smack it down on the table, when you measure it, that it's forced to pick one. It collapses into either heads or tails. That's superposition in a nutshell.
And now for our third and final weird rule, and honestly, this one might be the wildest of them all. Entanglement. You can link 2 particles together in this special way, and then, no matter how far apart they are, we're talking across the room or across the galaxy, if you measure one, you instantly know the state of the other one. Instantly. It's like the universe has this hidden connection that breaks the cosmic speed limit.
You know who really hated this idea? Albert Einstein. He thought it was so bizarre that he famously called it spooky action at a distance. He just couldn't get his head around a universe that was connected in such a strange way. But as it turns out, the universe really is just that spooky.
I know what you might be thinking. This all sounds completely made up, right? How on earth could we possibly know any of this is real? Well, that brings us to our next part. These aren't just wacky ideas. They are backed by some of the most brilliant and mind-bending experiments ever done. For example, you've got the double slit experiment. That's the one that proved, beyond a shadow of a doubt, that a single particle can act like a wave when no one's watching it. Then there are other experiments that showed light comes in little energy packets, and that things like a particle's spin can only be up or down, nothing in between. It's quantized.
And it's not just what we see in the lab. The math behind all of this is incredibly solid. There are these famous equations, like the Schrödinger equation, that don't just describe this weird world, they predict its behavior with jaw-dropping accuracy.
So, okay, weird particles, spooky connections, why should you care? What does any of this have to do with your actual life? Well, it turns out everything. Because your world is a quantum world. This isn't some far-off theory, it's the tech you use every single day.
The phone in your hand, the computer you're on right now, it only works because we understand quantum mechanics. The tiny little transistors that are the brains of every computer chip, they're quantum devices. Lasers for fiber optic internet? Yep, quantum. MRI machines in hospitals? You guessed it. And it's also the key to the future, with things like quantum computing on the horizon. Let me put it this way. What percentage of modern electronics relies on quantum physics? 100%. All of it. Without this spooky science, the world as we know it today, our entire 21st century civilization would simply not exist. And that leads us perfectly into our final section, the ultimate mystery. Because even with everything we've figured out, with all the incredible technology we've built, the quantum world is still profoundly, deeply mysterious. And you know what? That's what makes it so beautiful. You know, the brilliant physicist Richard Feynman, a guy who won a Nobel Prize for this very stuff, once said, I think I can safely say that nobody understands quantum mechanics. So if your head is spinning right now, don't worry. You are in very, very good company. It's just a reminder of how wonderfully complex and fascinating our universe truly is.
So, we've journeyed down the rabbit hole. We've seen the weird rules, the solid proof, and just how much our modern lives depend on it all. But it leaves you with this one final, thrilling question. If this is what we've managed to uncover so far, what other secrets is this spooky reality still waiting to reveal?